question 3 says a mass of 0.300 kilograms is rotating in a horizontal circular path of radius 0.80 meters. On a, let's put an extra 0 on there for being consistent with significant figures, on a friction-free table. It's attached by a string to a peg at the center of the table. So draw a free body force diagram. I think perhaps the first thing is to make sure we're picturing this correctly. So if this is my table, somewhere on my table there's a peg that's sticking up out of the table. So I'm picturing it a bit like a drawing pin. And attached to this there is a string attached to an object of mass 0.30 kilograms, and this is going around on this friction-free surface. So it's going to keep moving at a constant speed, but the tension in the string is going to force it to go in a circle. So when I draw my free body force diagram, which is what the question's actually asking me to do, I need to sort of pick a point. Well, I'm going to pick the point when it's about here on my diagram, so that the tension is going to be acting horizontally to the right. So I'm looking with my eye line level with the table, so from somewhere over here as it's at this point. So this is the tension in the string. Let's write its full name out. Then there's two vertical forces acting. There's the weight acting down and the contact normal reaction force acting upwards on the object, and we think these two should be the same size. So it's just the tension is the resultant force, which is why the thing's going round in a circle. B, find the force which the string exerts on the mass, that should say, on the mass, when the mass is moving at a constant speed of 0.345. So in this particular case, the tension provides the centripetal force. So we know the size the tension should have should be equal to mv squared over r. In this case, we've got a mass of 0.300 going at a speed of 3.45 meters per second, and we're going to square that because it's v squared, divided by the radius is 0.800, which gives us a value of 4.46 newtons.